begin. It's 11 o'clock. Oh, right. Wednesday, I guess that's September 16th. Thank you for noticing that. All right. So the first announcement is that your homework assignment number 3 is due on Wednesday. And of course, that's due before our class meeting. And today we're going to be talking about ways that we can solve for the unknown interest rate and find out the number of periods until break even occurs. And so this is looking at things a little bit differently than we have so far, where we've been changing the amounts from the future to the present and vice versa. Before we start on that new material, just one other announcement. I'm going to be using Microsoft Teams this semester for my office hours, and so if you want to place a call to me, a video call with Microsoft Teams, then that's great. But I'm not going to be using Microsoft Teams chat feature. And so if you have a question for me, then you need to send that by email. That's the best way for me to be sure to get your message. I don't have ready access to Teams over the weekend, for example, and so if you're sending me a question about a homework assignment or some other issue that you want to get in touch during the weekends and the evenings, email's a lot more likely to get to me. So send your messages to me that way. All right, so homework number 3, due Wednesday. Now, in the last class meeting, remember what we did in the in-class exercise was we were looking at the form of a combined gradient and an annual series together. And so what we did is we deconstructed that combined series into 2 individual series. And in the homework assignment, you're doing that same thing, where you have a base amount. In this example that we worked for our in-class exercise, the base amount was 400 during each year, but then a gradient was built on top of that. The homework assignment that you're going to be submitting on Wednesday takes things one step further. And let me bring the assignment up just so that we can very briefly touch on it together. Because what I wanted to point out is the time delay that you have to kind of deal with. All right. In this problem, in problem 3. And so in problem 3, you'll notice that the gradient begins many years in the future, but our time 0 is here, but the gradient, we don't actually see the first effects of the gradient until year 4. And so what I wanted to mention is that this diagram shows us the typical form of a gradient. And so that typical form is that the 0 year is 2 years prior to when you see the first gradient effects. And so on the homework assignment, where do you first see the gradient effect? It's here in year 4. And so that means that year 0, or kind of like a pseudo or a quasi year 0, is actually here in year 2. So the amount that's at year 0 needs to get to year 2 before you distribute it into the gradient. So I give you kind of those same hints here in the text, but I wanted to illustrate that more specifically. So that assignment due on Wednesday. I just wanted to give you a little bit of additional instruction related to that. And of course, the interest factors are here for all manner of the conversions. And in the table lookup, I think that you don't have all of those same columns. If I remember correctly, in the table, one of the hints that I give you on the homework is that you should use the inverse. Let's go back to that if I still have it up. I might have closed the assignment. All right, so in the homework 3, that same problem, I tell you that you may not have the G to P column. Oh no, wait, I think it's you don't have the P/G column, but you do have the G/P. And so if you divide rather than multiply by the factor that's given, then you can use the table lookup method for that problem. And then, of course, you can always verify your answer by calculating your own interest factor using these formulas that are provided. All right, so now the new material. This figure illustrates balance or equilibrium. And the reason why I show you this picture is to help you remember what you're looking for when you're solving for an unknown interest rate. You're looking for balance. And here's another way of thinking of balance. It's an equilibrium between things. And the equilibrium that we're looking for when we solve for an unknown interest rate is we're looking for the present value of the inflows and the present value of the outflows to be equal. And so given some cash flow diagram, if we are looking for equilibrium, we're looking for the interest rate that would make $23,000 in the present equal to $5,000 per year every year for 6 years. And so there is some interest rate that makes these economically equivalent, just one. And so what we're going to learn today are some techniques for solving for an unknown interest rate. Now to do that, we're going to be using Microsoft Excel for the first time in our course. And the tricky thing about you using Microsoft Excel is that if you have it on your screen to do the in-class exercise, then you can't see what I'm demonstrating. And so this is where it will be particularly useful for you to have a second screen. You can connect your laptop to a TV, for example, and then Microsoft Windows gives you the option to extend your monitor so that you could put my demonstration on one screen while you're doing your own work and calculations on the other screen. So that's one way to see the second screen. Another would be to watch the lecture on a phone or on an iPad, a tablet of some sort, and then that leaves your computer screen free so that you can do the Excel calculations there. So you're going to have to find whatever solution works well for you, but for much of the semester, we're going to be using Microsoft Excel because it automates a lot of the calculations that otherwise would be really tedious and hard to do just by hand. So finding the balance is what we're going to be solving the unknown interest rate to be able to do. We'll be looking at the present worth of an annual series and asking, is that equal to the amount that we know is already at the present? So we'll solve for I by doing that. And it's an iterative process, which is why it's so helpful to have our calculations on Excel, is because we're going to be testing out lots of different values of I, and we're looking for that perfect interest rate that makes balance between inflows and outflows. So whether it is in balance depends on finding the right interest rate. Here's a brief bullet point summary of the process that we're going to follow. I'll demonstrate this process today. We'll be given a cash flow diagram or a problem statement that we could generate a cash flow diagram with. And so with that cash flow diagram, our general process will be that we're going to discount any amount that's in the future to the present. And we're going to have to start with a guess interest rate because remember, we're solving for an unknown. So you can't discount the future values if you don't yet know the interest rate. So to kind of kick the process off, we start with a guess, and then we're going to try and refine and improve on that guess. So the amount that we take to the present, whatever that was in the future, we'll combine with the amounts that are already at the present. And then we're going to keep changing our guess value of the interest rate until the inflows and the outflows are equivalent so that they're equal. And then that will tell us that we have the equilibrium that we're looking for and we've solved for the unknown interest rate. So that's kind of the numerical technique, is it's an iterative process. Now, when we use Microsoft Excel, one of the tricky things is that it's going to automatically change the sign of many of our calculations because it assumes something. It assumes that if you give it a positive amount, that means it's an inflow to you, and so it's going to be solving for the outflow that would make it equivalent. So using Microsoft Excel's built-in formulas that convert between, for example, a future amount that's given and a present amount that's unknown, it's going to switch the sign. And so if we want to override that assumption, if we actually want to know what is the future value, the present value of a future inflow without it making it into an outflow, then we have to put the negative sign into Excel because of what it's assuming. It's assuming that the question is, what would you have to deposit today to make a certain withdrawal in the future, where sometimes we want to know not what is the deposit that would have to be made, but what is the present value of that future amount. So if this is what we're trying to do, if we're trying to just discount to the present but not change the sign, then we have to override what Excel's going to do by putting the minus sign in ourselves. So I wanted to give you advance warning that sometimes I'm going to be typing the minus sign into the equation, and the reason why is because of what Microsoft Excel kind of has as a built-in assumption. The negative sign has to be put in. All right, so let's open up today's in-class exercise. We're jumping straight away because the demo is a little more involved than some of them will be this semester. Let me drag it over here. I hope that you've printed this off already. All right, so here's the problem setup for the first question, where we're going to be solving for an unknown interest rate. A contractor purchased equipment for $60,000, which provided income of $16,000 per year for 5 years. And so that's going to be the first thing. Draw a cash flow diagram on the paper. We don't know the interest rate, but we can sort of summarize that there's an outflow at the present because of a purchase and an inflow for 5 years. Each year is 16,000. So draw that sketch on paper, and then I ask you to use the table lookup method for part B and part C. And so find the present value if the 16,000 per year is discounted at 10%, and then what's the net present value? So both of these, it's the net present value. That means combine the income discounted to the present with the outflow that's already at the present. So do that for 10% and 12%. Here are the factor tables that you can use to calculate what are those amounts. So discount the 16,000 at 10%, then discount it at 12%, and find out the net present value for both of those. And the reason why is I think you're going to see is our answer for the interest rate we're trying to find is somewhere in between 10 and 12%. And so let's see what are the indicators that the interest rate is between 10 and 12. So let me pause for a moment and give you a chance to do these calculations, discounting the 16,000 at 10%, at 12%, and combining it with the outflow at the present. All right, so let me show you what we're doing here. So the cash flow diagram, we have an outflow of 60,000 and an inflow annual series of 16,000 each year. Ultimately, we want to know the interest rate. Now in part B, what we're doing is find P given A at 10% for 5 years, and so we can look up the factor from the factor table, and multiplying that by the magnitude of the annual series, 16,000, and that tells us it's 60,652 and 80 cents, just like Jonathan mentioned. But the question says, what's the net present value? So what that means is combine the cost of buying the equipment and the value of the revenue. So we're combining the inflow and the outflows both, and then the net means that we're going to have $652.80 of additional profit. All right, and let's see, the part B, that's good. Yes, you've got it there, the part B. So here's the part B. So if we're discounting the future revenues at 10%, what that means is that we have a positive profit. If it's being discounted at 12%, then the profit is negative. Now, the global implications of that we'll continue to talk about through the whole semester, but if we're solving for an unknown interest rate that brings these two into balance, that means that 10% interest is too low. 12% interest is too high. The interest rate we're solving for is somewhere between 10 and 12 because balance means that the inflow and the outflow are equal. So when we were discounting at 10%, the inflow is too big. When we discounted at 12%, then the inflow is too small. So we're looking for the interest rate that is between those two. All right, so the in-class exercise now asks, it says observe the instructor's Excel solution using this method. Sum of the present value of the amount is equal to 0. All right, so if you have Excel handy, then open that up on your computer. Well, maybe for now just observe. You don't necessarily have to follow along by setting things up the same way that I do. But here I'm going to do in-class exercise number 9, problem 1, unknown rate. Let me make that a little bit bigger. All right. All right, so we don't know the interest rate yet, so let's start with a guess. Let's just start with 10%, and just to make it clear, this is a guess. I think it's a good idea to put comments onto a spreadsheet when you can. Okay, so that's our interest rate. Now I'm going to start a table where I've got year, amount, and PV of amount. Okay. So in years 0, 1, 2, 3, 4, 5. And now I'm going to put the actual amount from the cash flow diagram. So if we just take another look at the cash flow diagram that we had before, we've got negative 60,000 and then 16,000 each year for 5 years. So here's negative 60,000 and then 16,000. Rather than typing that over and over again, what I'm going to do is I'm going to drag. Do you see there's a little bit of extra green down here at the bottom? If I click down on drag that, then it saves me from having to repeatedly type it over again. All right. Now, PV of amount. To tell Excel that we're doing an equation, we use the equal sign. So I'm going to type equals PV, and you'll notice as soon as I do that, it starts to prompt me with what this function is. And as soon as I put the parentheses in, it's going to start giving me hints of what comes next, field by field. So the first thing it wants to know, you can see in bold beneath that, it says rate. And so I'm just going to click in the location where I have my guess of the interest rate. I want it to always look in that same location, even when I drag this formula down and apply it to other rows. And so I need to anchor that, as it's called, anchor it with dollar signs. And so I can either type in the dollar signs like manually. The dollar sign in front of the B means always look in column B. The dollar sign in front of the 3 means always look in cell in the 3rd row. So it's always going to look in this same location even when I drag the formula down, and it could be relative references other places, but this is going to stay an absolute reference. And so I can either type it in manually, or if you press the F4 button, then it'll just do that for you. So that's a little trick there. All right, so now I do the comma, and now it says NPER. What that means is the number of periods. And so it's asking basically how many years does this amount need to be discounted from the future to the present. And so I'm going to click on this location because that's saying the number of years. And so now if I use that same formula in the next row, then it would look at just 2 cells to the left of where this formula is. And so then it would have year 1 and year 2 and so on. All right, so next comma, and now it's highlighting the payment, PMT. Now, we're going to skip over that because what we are discounting are individual amounts. Each row represents a single amount that we're discounting to the future. And so we're not treating each entry into this formula as a recurring payment. We're treating them as an individual amount. I hope you'll see what I mean when we do apply this through there. But for now, just trust me that what we want to do is just put in another comma without anything in the payment field. So I've skipped over it. Now I'm going to click on future value. Now, that's the last thing that we need to put in. The reason why future value is in brackets is that that potentially can be an optional field. But in our case, we want to discount a present value to a future value to the present. And then you'll also notice that the next field that's optional is type. And that's asking, is this the end of period assumption or is it a beginning of period assumption? And we're using the end of period assumption through the course. And so we can just skip over that and complete the equation with one more parentheses. I didn't put the minus sign in, and I want to show you what happens if you don't. So now it's saying positive 60,000. It has changed negative 60,000 into positive. And so that's what I was talking about when I told you that sometimes Excel will change the sign on you. It's done that. And so I need to override that by either putting the minus inside the formula to make it a negative 60,000. Red just means negative. And so let's change this from the default. Just click on currency, and then that's, seeing the negative sign and it not being in red, I think is the better approach. All right, so now I can just drag this formula down. I don't have to type it over and over again multiple times. If I drag this formula down by the corner, you see the little extra green that's in the lower right corner there. If I grab that and drag it down, then it's going to find the present value of each one of these years. Now you'll notice it changes. Each year it's getting lower and lower and lower. And the reason why is that it makes perfect sense. 16,000 5 years in the future is less valuable than 16,000 1 year in the future. If you only have to move 16,000, if you have to discount it by 10%, then it's going to have more residual value in the present than that same number of dollars that has been discounted 5 periods. And so that effect is made plain where the further you go into the future, the lower the present value of the amount. All right, so the last thing I'm going to do here is I'm going to sum, okay, and so I'll use the equals sum formula and just highlight all of these amounts. And 652.59. And if we go back to here, 652 was our answer. Now, we got into 80 cents. This is saying 59 cents. And the reason why is that we use the factor table. And the factor table isn't going to allow us to be accurate to the nearest penny in the same way that the built-in equations in Excel or the equation method will. Okay, so any questions so far? If you do have a question, please feel free to interject, with your microphone at any point if you need me to explain why I did a certain thing or repeat it because you missed something. The class meetings are recorded, but if you've got a question now. So Craig asks, where did you change Where did you change to 60K into a negative value? Okay. So I just put the minus sign inside here, right next to the reference to the amount. The alternate way to do that is you could just do it at the beginning of the equation. You could put the negative sign there as well, and it would have the same effect. So I just usually will put it right next to the reference of the amount. Okay, so what we solved for on paper said that you get 652 if you're discounting at 10%. Let's check this to make sure that it's set up correctly, because if it's 12%, then we get negative 2323. So let me change this to 0.12, meaning 12%. And as soon as I type enter, it's going to update all of the equations and the sum included. So negative 2323. So now we found the value of the cash flow diagram if things are discounted at 12%. All right, but what's the interest rate that makes these the inflow and the outflow equivalent? So what we're looking for, our goal, so to speak, what interest rate will make this equal to 0? If I do 11%, does that get me closer to 0? Because 0.1 is too small. 0.12 is too big. What about 0.11? We're headed in the right direction. What about 0.101? 0.102, we're getting closer. 0.103, we're still getting closer. 0.104. This is getting a little repetitive, right? So there is a way to automate the process of looking for that perfect interest rate. Here on the Data tab, if you click on Data and then What If Analysis and then Goal Seek, then that will allow us to say set this cell to a value of 0 by changing the interest rate. And as soon as we click on OK, what Excel is going to start doing is it's going to start plugging in lots of different values into cell B3, and it's going to keep changing what the number in B3 until cell C13 is equal to 0. So I'll click OK, and very quickly it finds that the interest rate we're looking for is 10.425%. So answer, 10.425% makes the sum of the present worth of outflow and sum of the present value of inflow equal. So we kind of add a conclusion there. By the way, it's a good idea if you are following along, when you follow along during the in-class exercises, if you save your work, you save these Excel files, then they can be a valuable pattern for the homework problems that accompany. All right, so are there other questions related to the first part of this example that I've showed you so far? Josie asks whether you'll use Excel on the exams, and the answer is yes. You will be using Excel on the exams. There will be problems where I'll specifically tell you to use Excel on this one, other problems where I'll tell you to solve it by hand. But you will need to have access to Excel on the exam. And of course, you can get Excel. The university makes it available for free if you go through Office 365, I think. So it's nice that the university picks up the licensing cost for that. All right. Now, what about the rate function. I think you, on the homework, need to know how to use the rate function. Let's see here. So if you just do equals rate, then it starts to prompt you on things to type in. So NPER, does anybody remember what NPER stands for?
Number of periods.
Good, that's exactly right. So in our problem, the number of periods is 5. So I can just type in 5. And now PMT means what's the amount of the recurring payment. Now I skipped over that field in the first solution that we did because I wanted to treat each row like an individual amount. In other words, the $16,000 in year 1, I just wanted to move that individual $16,000 to year 0. And then the next $16,000 in year 2, I wanted to individually move that to 0. In this case, though, we are going to type in the recurring payment amount. And so the recurring payment amount in this setup is $16,000. So I can just type that in directly. I could also click in a cell location where I have that amount typed. Either one will work. All right, so now comma, present value. So our present value is negative 60,000. All right, and now I can close the parentheses. And it solves, it says 10%. We know the answer is 10.4248%. It's just a matter of how many digits of precision are being shown. So here I can increase, let me click on our answer where it said 10%. If I increase that, 10.425%. So what the rate function is doing is it's essentially setting up a table just like we did, and it's solving for the unknown interest rate. It's, like iteratively doing that goal seek and finding, what's the interest rate that makes the inflows and the outflows equal to each other. So let me just show that real quick because it was so simple you might have missed over a certain part. So equals rate, parentheses, number of periods, there are 5 periods. The payment amount is 16,000 and the present value was negative 60,000. And then FV, type, guess, those are optional fields and we don't have to put any of them in this case to get the answer that we're looking for.
How do you make it show more decimals?
Yeah, so it is under the, just where it says percentage. So there's like increase and decrease decimals. So it's on the home toolbar, just underneath where it says percentage, you can do increase and decrease digits like that. Are there other questions?
Thank you.
Yeah, you're welcome. Any other questions? All right. The next part of the in-class exercise says a contractor purchased equipment for $60,000 that provided income of $8,000 per year. At an interest rate of 10% per year, how many years until the investment breaks even? All right. So the first way that you can solve this is by looking at the factor tables. And so right on the paper, you can define what is A, what is P, and then you can calculate based on this is P, this is A, and you can see that I've given you the 10% factor table, and that's the interest rate that the problem specifies is 10%. So that's why we're using this factor table. So let me get out my calculator here. What is P divided by A? So this is saying, what is P divided by A? So 60,000 divided by 8,000. Okay, I got 7.5. Anybody else get 7.5? Okay, so now if we look at the P to A table, if you go down, we're looking for where is 7.5. Okay, it looks like it's between 14 and 15. So the question is asking how many years until the investment breaks even. Now think about what's happening is if you were going to draw this as a cash flow diagram, you have an arrow down at time 0 because they paid 60,000 to buy the equipment, and then that equipment allowed them to have new income, so that means an arrow up, of 8,000 per year. So if you're going to get $8,000 every year, when do you break even? Well, you can't just add together 8,000 because you remember the money in the future is less valuable than money at the present. So we're having to discount that 8,000 every year and take the discounted amount to consider paying off the original investment. And so what I'm telling you is that if you go to this factor table, it's going to be between 14 and 15 years for it to pay off. Now let's look at the Excel illustration of that. So I'm going to start a new tab. Like I mentioned before, it's a good idea to save your work. So if we saved this someplace, then down here, start a new tab. So I created a new sheet so I could, name the first one problem 1 and then problem 2. Let me zoom in a little bit so that things are larger. All right. We have a known interest rate this time. So this one isn't starting with a guess like the other one was. This is a known interest rate. So given that I equals 10%. I'll just put that note in there to remind myself. And now some column headers. There's the year, the amount, the PV of the amount, and then a new column title, cumulative PV of the amount. And I'm making these column widths the right width. You can either drag it side to side like this, or if you just double click at the top, then it'll automatically make it the right width. Okay, so this problem statement just says that you buy the equipment and then it has income, and it doesn't say how many years that income continues. We're not exactly sure how long until the investment breaks even. So let's just look at 17 years. Let's see if it's within the first 17 years. So 0, 1, 2. Now I don't have to type all the way through 17. What I can do is I can highlight, and Excel is going to detect the pattern that it's increasing by 1 every year. So when I use this green anchor point down here and click and drag, then it's increasing, and I want to go down through 17. Okay, and the amount is we paid 60,000 to buy the equipment, and then we get $8,000 worth of revenue every year. Okay, now I can click and drag, or I could just double click, and it's going to extend that series all the way down as long as there's information to the left of it. So you see that green anchor point that I've been clicking and dragging on? If I just double click, then it fills the same pattern all the way down through. All right, so now the PV function. We want to find the present value. So what this is going to do is it's going to say discount the 8,000 to times 0 at 10%. Discount this 2 years. discount this amount 3 years, discount this amount 4 years. We're going to take all of those future amounts to times 0. So the function for that is PV. The interest rate, I need to lock the reference to this cell because I want it to always look there for the 10%. Now I could type in 0.1 and it would be right. I'd get the right answer, but then that would eliminate the flexibility of trying to play around with different interest rates. You know, remember in the last in-class example how I was able to just change the value in the interest rate cell and everything automatically updated? If you key in the value rather than refer to a location, then it won't work. So that's why I want to refer to this location and press the F4 button. And when I press the F4 button, then it automatically puts in the dollar signs. Okay, comma, NPER, the number of periods. So I'll click on the year. And then I'm going to have the double comma to skip over the payment field and negative of the amount. Close parentheses. You know, actually, Excel's smart enough I don't even have to close parentheses. It'll know what I mean. It's not smart enough to format things nicely by default. I don't like the red and the parentheses. I think it's better if we change it. Just click on currency, and now it has the minus, and it's not red anymore. All right, so now I can click and drag that down through, or you know, I could just double click and it continues it onward. And we see that same pattern as we did in the previous example where the amounts are getting smaller and smaller and smaller. And so what this is saying is that if you discount $8,000 17 years to the present, it only has a present value of $1,583 essentially. Whereas 8,000 next year has a present value of 72.72 because it hasn't been discounted as many years. So that's the same pattern as we saw before. Now, the cumulative present worth. At year 0, the only thing that's happened so far is that we've paid 60,000. So I'm going to say equals this. Okay, so at time 0, we've spent 60,000. After the first period, we have our previous amount that we haven't yet recovered. You can think of that as that's how much money left your wallet that you haven't gotten back yet. So you have the previous amount plus the new value for what came in this year. So the present value of that first $8,000 means that the present value amount after 1 year of operation is negative 52,727. And now if I continue this trend down, click and drag through the rest of the series, what we're looking for is the break-even point. And after 14 years of operation, we're not quite broken even yet. And then after 15 years of operation, we've broken even. And so when we were looking at this on paper, we were looking, you know, if A to P is 0.133, we can go to the A to P column, or if we do P divided by A, did I have it on this one? I said, what is P divided by A? And so it's the same answer whether we look A to P or P to A. So it was 7.5. We were looking at between 14 and 15 years. And we found the same thing with Excel, that now after 15 years, we finally broken even. The way to think about it is, you know, what if you borrowed this money? You went to the bank and you borrowed $60,000 and the bank wants 10% interest. What it means is that all of these revenues in the future are going to go to the bank until you finally break even. And once you've paid off the loan, then the rest of the profits from there are your profits. So that's why it goes from negative to positive, is you finally covered that original investment, and then everything else that you earn is profit once the equipment has been paid off. So these are complicated ideas. You know, used Excel for the first time today, and I've showed you a lot of things. I showed you, for example, how to put in the PV function. We talked about the complexity of the minus sign that has to go into that function. We did the goal seek, where we were, rather than typing in over and over and over again, we used data, what if analysis, goal seek to kind of automate that iteration and guessing game. So if you feel overwhelmed, don't get too stressed out. We're going to get so much practice with this stuff through the semester. But if you weren't able to keep up today, if this really went over your head, here's what I suggest is review the lecture and watch the video, pull it up on YouTube on your phone, and then do the same thing that I was doing. You need to practice this. There's no reason why you should expect to understand it if you don't practice it. And most people, I think I've heard that the average amount of times that you need to practice something until you've figured it out is like 7 or 8 times. Once you've done something 7 or 8 times, then you're going to understand and retain that information. So I'm not saying that you have to go through this in-class exercise 7 times, but what I am saying is that if all you did today was just observe me doing it, you're not there yet. And so what you need to do is replay the lecture and solve the in-class exercise yourself using Excel. All right, that's all the time that we have for today. Remember that homework 3 is due on Wednesday. If you have questions, I'd be glad to hear from you. I have I've got office hours today, so you can call me on Teams or send me an email. Otherwise, hope you have a great day, and I will see you on Wednesday. Bye-bye.